Welcome to the final talk of the Bioinformatics, Computational Biology, and Neuroscience track. Again, if you have any questions during the talk, please post them to the Slack channel. It's track-bioinformatics, and I have a post there that you can reply to. It's my pleasure to welcome Enrique Molina to talk about cloud-optimized formats for genomic data, and take it away.
Okay, so let's start. I will explain today Dataplug and how to deal with stream data analytics with on-the-fly dynamic partitioning of unstructured data. This was a work done in Universitat Rovira i Virgili, which is a university in Spain, in the context of the Extract project. I will talk a little bit more about this previous to the presentation of the technical things. About who are we? We are the Cloud and Distributed Systems Lab. We are sit in Tarragona. This is a city close to Barcelona in Spain. And in our research group right now, we are very active because we are very well funded right now. We have got 4 active projects near data, which address computation close to the data, cloud skin, which is the computation in the compute continuum, extract, we deal with extreme data. I will explain later, which is extreme data, and CloudStart, that is a mobility program. We are publishing in top-tier conferences, which is a pleasure for us, like, for example, Middleware, CC Grid, or right now we are presenting a job this week in ATC. We are also a group that I think that is well positioned in collaboration with different strong partners, like, for example, IBM, Dell, or collaboration with European Molecular Biology Laboratory. And I think that an important peculiar thing maybe from our research group is that we are not only focused on research, which is a very common thing in a research group, obviously, but we are also trying to make the solutions to have got a production-grade readiness level. And this happened with lithops. I told about lithops in the tutorial days ago. I covered also in the tutorial Dataplug, but I will talk today also about Dataplug. But these 2 solutions are production ready, so we are trying to give to the world solutions ready to use. I need to refer also to all the people that are in the group. They are making this possible. Pedro, which is my principal investigator, that's me, Enrique Molina, but we have got a lot of other members that all of them are contributing to that project and are making this possible. So let's start with the technical stuff. Let's start with the context and the problem that we have got if we want to address. The context right now is that internet or the universe is starting to be plenty of extreme data. We used to say that extreme data is data that is that have got extreme volume, speed, complexity, or variability in values. This means that data can be huge or can have got like different rates of arrival, can be very complex formats, or can be very varied. But basically here we can see one example of a repository. This is the National Cancer Institute, and this is a repository of files, a data lake that we have got accessible for free in internet. And this repository is plenty of unstructured scientific data, in that case, for that domain, but we need mechanisms for efficiently access to that data. And we will show later, a minute after this, that this is not possible so far, but Dataplug will solve this. So there is a challenge between how to process this data with the cloud distributed computing frameworks that we have got. So also the size of the data that we will deal with is huge. For example, we have got this example that have got like 9 petabytes of information. That is a lot of data. So when we want to process this data, what we tend to use is the cloud, because the cloud is like an infinite amount of resource, a pool of resource that you can hire on demand, and you can get a resource as needed. This one example of this is object storage, and you can use object storage like an infinite storage system, because is kind of infinite. So what we want to use with the huge files that we have got in the stream data repositories is to fine-grained data partitioning that files for enable the exploitation of the scalability and the parallelism of the cloud. Of course, maybe we hang off a file that we can process in just single machine, but maybe this is totally impossible because the execution time can be so long. So what we can do is to split this file in different chunks to enable the parallel process of this data. And this is what we will do in this presentation. So typically, we split the data in different chunks, and that chunks are scattered to different executors, different workers that can be Spark workers or can be different EC2 machines, different instances that will compute the data in parallel. And this is possible for several formats. For example, here we have got that this is possible for tabular or structured formats because we know the schema of the different files that we have got. So it's very simple for the different computational frameworks to know where is the different data in the different chunks and how to access to the data to retrieve the information for each chunk. This is also happening in cloud-optimized file format. A cloud-optimized format is a plain format that is enriched with metadata information, and this metadata is allowing to query data over S3. So we can use this metadata to retrieve the different partitions that we need to retrieve and get the actual data using this information that we retrieved from the metadata. But this is not possible in unstructured data format because an unstructured scientific data format has got like no schema and is very difficult for the computational framework to know how to address this format in order to partition it. So what we can do is, this is a very naive, but this it's a solution, not a good one, but it's a solution, is how we can do it is, okay, we have got the big file and we want to split the file in several chunks to process it efficiently in the cloud. So we download the file, we in runtime create the different partitions, and after this we update the different partitions again to the object storage. But this is the way in which we need to do it because, as I said, cloud distributed computer frameworks allow only to process individual unstructured files because they don't know the schema of these files. But this comes with different limitations. The limitations are here because processing for chunking file is challenging because there is a variety in format and in size for the different formats possible. This is duplicating the data in S3. We need to download the actual data, the original one, and we need to re-upload all the data again in different small chunks. So we are using the double of data. What happens if we have like 10 terabytes in object storage? If we want to process all this data in a parallel way, we need to duplicate this amount of data, and we will create like 200 petabytes, and this means a lot of money, a lot of wastage of money. And also, this is creating a huge data movement. We are wasting more computing time because we not only need to download the data, but also we need to upload the data. Again, what happens if we decided in a bad way the number of chunks that we need, and after this we realize, okay, I need to change my number of chunks, and I need to create a new partition. I need to recompute this, and this is a heavy computation. So the result of this is that many unstructured scientific data repositories are not prepared for its efficiently computation in a parallel way in the cloud. And this is the problem that we will address today and we will solve with Dataplug. But before this, I want to make the statement of the problem and continue. So what happens is that data partitioning is key for efficiently process the data in the cloud. The static method is not ideal because of its several limitations. In object storage, we have got a very high bandwidth that we can exploit for access the data in parallel, but this is not possible so far for the unstructured formats. And of course, we have got optimized version, cloud optimized versions of different formats, but maybe are not enough because we need to translate one legacy format to the cloud optimized version, and that formats are heavy because they allow us to query. They are not thought for partitioning, they are thought for queries on different information in S3. And in other words, maybe cloud optimized versions are not enough for the partition purpose. So the result is this. The result is this diagram here, which is saying, okay, we can access in a parallel way without recomputation, without static partitioning to the tabular format, to the structured formats, but it's not possible to access in an efficient way to the scientific unstructured formats. And we will solve this with Dataplug. So Dataplug is the framework that proposes this novel data management model that we will use to efficient on-the-fly dynamic partition the different files that we have got in S3 or object storage. And with this, I want to read here the different features that Dataplug have got. First, with Dataplug, we are creating a framework, which is a Python framework that all of you can use. It's open source in GitHub. We are enabling the efficient parallel access to different formats, unstructured scientific formats. But important, we are hiding the complexities of preprocessing and partitioning the formats, because just imagine each format is different, and for example, you can deal with astronomic format, and you are not very expert in this format, but you need to split this format and implement the logic for split this format, and this is difficult. With Dataplug, we are providing you the function that do this, and you only need to consume that functions. And with this, we are hiding the complexity and making simpler to partition the data. And Dataplug is also extensible. With Dataplug, we are achieving to have got a structure in which if you realize that one more scientific format can be integrated into the platform, because of course there are more possibilities that are right now. This is totally extensible. You only need to implement an interface, and after this, a new format will be available for the people and can be used in the Dataplug ecosystem. So, with this, I want to talk about the workflow of Dataplug and how Dataplug is enable the parallel data access to that unstructured data. So, the diagram here is so simple and so informative. The first of all that we need to do is to download the data, and after this, we won't split the data in different chunks. No. What we will do is inspect the data and create different indexes and metadata that we will need to know how calculate the different partitions that we will calculate after. After this, we will register and save, upload the different indexes and metadata to the object storage. With this, we kept the original data totally humidified, and we are not duplicating the data. Usually, the size of the data is negligible. For example, for gigabytes files, the size of the metadata is like kbytes. So we are not duplicating the data like in the previous static method. We are just creating a tiny amount of information and saving it to S3. Of course, in this part here, in the calculation of the metadata, it will be different strategies for each different format. But this is extensible also. You add a new format, you need to implement the preprocessors logic for this format. And here we have got the other part that comes after the partitioning, and this part is how to retrieve the different partitions and map the different partitions to the workers. So with this, what we will do is cover here in this diagram how this woman is retrieving the different partitions of the data step by step. So the first thing that you need to have got is your data preprocessed in S3. After this, you need to say to Dataplug, okay, I want to apply this partition strategy in this file. And with this, Dataplug will calculate the different data slices of your data. A data slice is a lazy evaluated version of your partition. It's not the actual data. It's just the logical, the virtual partition that you need to map to the different workers. After this, the only thing that you need to do is to call to your distributed framework that can be PySpark, Task, Ray. In our group, we usually tend to use Lithops, which is serverless framework. And the different workers in this framework will perform the get operation. The get operation is an operation that you execute in the data slice and is the actual retrieval of the data from S3. Is that part here that is making the actual parallel HTTP GET byte request to S3. So in that way, we are allowing the parallel access to the different chunks of the data in S3. And after this explanation, I will cover some different use cases or different formats that we have got so far in Dataplug. Maybe the first simplest format that we can cover is LiDAR. LiDAR is a format that is a cloud of points. LiDAR is a binary format for three-dimensional point clouds data that represents the Earth surface morphology or the shape of a building and so on. And here the challenge is to scatter the different points that compose the map in different workers. So to solve this, we can use one last tool, which is indexing that points and are creating tree structures for solve this problem. After this, we will have got a cloud-aware LiDAR, which is same LiDAR legacy format, which typically tend to use a LAS format, but this legacy format can be parallel downloaded using Dataplug. Another example is FASTQGZip. FASTQGZip is a more complex version because this is a compressed format. It's a compressed format, and in a static version, we need to download, decompress, create partitions, compress again, upload. But here we can use GZip and one gzip tool that we have got, which is gzip index, allow to create different, to decompress the file with different entry points. And with this, we are enabling the FASTQGZip to be cloud-aware again. Another different format that we are supporting is directory-like format. In this case, is measurement set. Measurement set is kind of complex format used in radio astronomy for interferometric observation data. And the challenge here is that we have got a time series with some common data and some particular data that we need to scatter into the different workers. So the solution here is to identify the different files that are common to the different partitions or the different files that need to be scattered to the different workers and apply the solution. The solution is the part is common. We broadcast that part to all the workers. The part is like an exclusive part. We need to scatter this data to each worker. And with this, we have got the cloud-aware version of the measurement set. But also, we are covering the cloud-optimized and tabular structure formats. And that means that under our simple Dataplug API that I will explain in the next slide, we can also use CSV, COG, COPC, and different cloud-optimized and tabular formats, because the operational directives of the framework match really well. You only need to partition your data and retrieve the actual partition. And this is possible also on top of these formats. Here we have got a snippet, very simple snippet, with the different operation that we can do with Dataplug. And you will realize that this is very simple API, because only thing that need to do after imported different dependencies is to create your cloud object, The cloud object is the declaration that is saying to Dataplug, okay, you will use this file that appears here, and this file is a FASTQGZip file. After this, and only once, we need to say to Dataplug, okay, you need to pre-process this file. And this is totally transparent because the logic of the pre-processing is declared behind the scene by Dataplug code. So you call to this operation. Obviously, if the pre-processed data is created, the pre-process just skip to pre-process it again. After this, we partition the data. This is creating the lazy evaluation of the data slices, not the actual data. And with this, we need to say to the framework, okay, you need to use this. You need to use this partition strategy, which is the logic that you will use. This is behind the scenes also, but you need to specify to the framework. You need to use it. And we need to declare the number of partitions, or usually the size of the partitions. After this, what we will do is to create, in that case, a dash bag of task. And after this, we have got different workers, different dash workers. And for each worker, we will execute the process FASTQ data. What each worker will do is to execute the get operation. The get operation is the actual retrieval of the data, the HTTP range request to get the data. After this, I want to give some insights and some validation of the framework that we have got. We experiment with FASTQGZip and LiDAR in this presentation, and we are covering 2 points. The first is how Dataplug can reduce the compute time and storage costs, and the second is how Dataplug can benefit, how the benefits of the dynamic on-the-fly partitioning can be applied to avoid in-cluster partitioning and to allow the zero-cost repartitioning to prove with different configuration, different number of chunks. Here we have got a comparison for FASTQGZip between a static partition method and the cloud-aware preprocessing. The blue bar is basically the static chunking with the FASTQ compressed in S3. And the red bar is basically the dynamic partition of the file using Dataplug implementation, which is using gzip index tool. With this, we can see that in all the different sizes that we have got, we are using only a third part of the time to perform the same operation. Here we can see also with FASTQGZip file how we can leverage that opportunity that the Dataplug is giving to us to create different partitions, different number of chunks with the same created metadata. And what is this important? This is important because the number of chunks that you choose matters, because the execution time, the partition fetch times, and the processing times are different depending on the different chunks that you created. And here in the left plot, we can see how the bigger is the number of chunks, the less is the execution time. But there is a trade-off, because here in the right plot, we can see how in price terms, the bigger the workers, the more expensive is the execution. But it doesn't happen with the time, because, for example, for this free execution, the execution time is almost the same. So with this, in other words, with this, what we can see is to prove different configuration and find the optimal one, which in this case is this, the red arrow one. Here with LiDAR, we have got another comparison. This comparison is comparing conversion from LiDAR, for plain LiDAR, to cloud optimized point cloud, which is the LiDAR cloud optimized version, versus preprocessing a LiDAR directly with Dataplug. In the top plot, we can see how the preprocessing time is like 71% better in use Dataplug. And in the bottom plot, we can see how much the metadata is smaller if we use Dataplug. It's like 99.8%, and this is a huge difference. This is because cloud optimized point cloud is creating a lot of stuff to allow a lot of queries of the data. But for partitioning, we only need a tiny part of this data, because we don't want to make a lot of complex queries. No, we only want to scatter the data in different workers. And using Dataplug, we are avoiding to use more time and also to use more storage. Finally, here we are demonstrating how also with Dataplug we can retrieve directly the partition from object storage, and we can avoid the in-cluster repartitioning that happens, for example, in an array deployment. Here we have got an array deployment on top of Amazon EC2 and two plots, one with in-cluster repartitioning and one directly using Dataplug within the fly partitioning system. With this, we are basically achieving to skip this part of the in-cluster partitioning. And with this, we achieve to trigger the scale-up events earlier. And with this, we can save like 28% reduction in the runtime. So finally, conclusions. With Dataplug, we are covering the on-the-fly partitioning of scientific data, and we are focusing in the previously uncovered problem for unstructured scientific datasets. With this, we avoid to do the burden static partitioning method, and with this, we demonstrated that we can achieve benefits for two representative formats. And here, the funny chart, the funny diagram in which we can see, okay, previously we couldn't cover this green part, but right now, with Dataplug, we are covering the tabular ones, but also we are covering the unstructured scientific data. Finally, the current status of Dataplug now is that it was accepted paper in CCGrid, a well-known systems conference. Right now, it's an open source Python library. You have got it in GitHub. But the most important part in this slide is the call to the action. Please, maybe you have got use cases that can be solved with Dataplug. Please don't hesitate in use it. Or maybe you like the Dataplug model, but Dataplug doesn't include your format so far. Maybe it's a great opportunity to think about it. Think about if it is possible to integrate your unstructured scientific format with Dataplug, and after this, peer the solution to the project and continue contributing with the cause. So, thank you very much to all of you. I will be very happy to answer to your questions.
All right. Thank you. Please post your questions to the Slack channel. We'll start with Deepak Cherian asks, can a dynamic partition be smaller than the on-disk or static partitions, for example, with TIFF or netcdf? If not, then there is always a case for expensive repartitioning on disk, correct?
Typically, the size of the dynamic partitions tend to be the same of the static ones, but the thing is the permanent storage. If you want to operate over your partitions and you need to do it with the static method, you need to recompute your partition, and that means that you need to use the double of storage in S3. But with dynamic partitioning, this is not necessary because you are only created a tiny pieces of metadata that you will store in S3. And with this, you will retrieve the same information. The information will be the same. There is no difference between the ingested data in the dynamic approach or in the static approach.
Chad Smith asks, does Dataplug support BAM? Can the metadata be stored anywhere?
I think it's a great opportunity to integrate BAM because it's not integrated so far. I don't know what a BAM is, but I think it's a great opportunity. As I said in the call for the action, yeah. Who was the person who asked this question? Nobody?
Maybe not in the room right now.
But anyway, you can integrate it. We can discuss about it. Of course, you can contact me. I'm Enrique Molina, of course, and I will very pleased to talk about it and see if this is possible. If the model matches well between BAM and Dataplug.
Okay.
Yeah.
Peter Sobolewski asks, Are you familiar with virtualizar? If so, can you comment on how your approach would compare for array-like data, for example, with NetCDF and TIFF?
Yes. I was in the virtualizar talk. It was really interesting, of course, but the approaches are different and the purposes are different. Virtualizar is trying to make NetCDF or other legacy multidimensional arrays to be like the cloud-optimized version, of course. But this means to execute a lot of operation on top of arrays, like for example, some value, all the other common operations that you can perform on top of arrays. But this is not the purpose of Dataplug. Dataplug is only focusing on partitioning the data. So there is like a kind of overlap between the vision, because virtualizar is like cloud optimizing legacy arrays, and Dataplug is cloud optimizing legacy unstructured scientific data. But the difference is in the purpose. The purpose of virtualizar is provide all the different operations that you can perform in arrays. With Dataplug, it's just partition your data. That's the main difference.
Okay. Any more questions? Please add them to the Slack. I have one quick question.
Yes.
So you mentioned that you support, or Dataplug supports FASTQGZip, or
Yes.
GZIP FASTQ files. Would this approach also, would a similar approach also work for any kind of GZIP file, creating that index?
I'm not pretty sure about the right answer on this, but I think so. I think so that because the GZIP index tool is providing you the ability to decompress some piece of different files, just going to the right entry point that you need in the actual file. So I think so. I'm not pretty sure, but I think so.
All right. Let's please thank Enrique and Molina.